So this PPT basically deals with what are the different types of sections within ADAMs or different types of structures that we have within the entire ADAM area. One is the ADSL, which we did. One is, as you know, occurrence data structure, which is based on the occurrence data sets or events data sets, basically, like adverse events, critical events, the analysis data sets on those. And lastly, for the basics data structures, which is BDS, which is LB, yes, LB data set, EG data set, though these ones. So if you see, we were speaking about stratification variables, remember? So these are some of the stratification variables in ADSM, like age group, character description of a grouping or a pooling of a subject's age in analysis. Remember, we did this age group below 35 and above 35. And then also we have A age, analysis age. Suppose we have derived the age in a certain way. Suppose we have got the age in a certain way from the participants, but we want to make the age a little bit different. Like starting from a particular date, we want to calculate the date. So that would come under a different age category, which is called analysis age. If you see age used for analysis, that is derived differently from dm.age. So this is basically dm.age which we are taking. dm.age. Age is required if age is calculated differently than age. Understand? So we also have an analysis age. Here is a short snippet of how we are actually calculating the age. You see, age is 29 and it belongs to age GR 18 to 65. You see, data ADSL set ADSL length age GR1, age GR2 is 200, age GR1, age GR2 is 200. So we have two age groups. That's why you have age GRY. If we want to have more than one pooled group, we have that. And if we have more than one sub age GR1, we can pooled number it as 1, age GR2 we can number is at 2. Similarly, parameter, exactly the same concept here as well. If you see, if A age less than, greater than null and less than 18, then age GR is less than 18. This is one group. Else, if age is greater than 18, less or equal to 65, then we do age GR is 18 to 65, and age is greater than 65, then we have age GR1 greater than 65. So see 18 to 65, it's 29, 18 to 65, 32, 18 to 65, 70 greater than 65, 65, 18 to 65. Like that, we have done the age GR. Again, what we have, if age, A age, like now we are coming to this part. If A age is greater than 0, less than 35, then age GR2 is less than 35. And greater than 35, at least 35 years old. So we only have two grouping categories in age GR2. But we have three grouping categories in HGR1. HGR1 is the name of the variable according to the first grouping algorithm, not the first age category. Understood this part? This is something that we have done in ADSM. So these are pooling categories. Priyanka, understood?
Yes, yeah.
Okay. Then we come to BDS, because OCCDS and BDS, the major difference is that in BDS, we are deal with parameters. We deal with findings, basically. Like lab. That is why, if you see, in BDS, we are more concerned about param N, param CD, parameter. What is the parameter? Because we have got some parameters based on which we have results. And adverse events, we are more interested about with date, because it is an event that has occurred. When did the event start? When did the event end? What was the severity of the event? What was the seriousness of the event? How was it related to the drug? All these are OCCDS. All these are OCCDS specific variables. If you see, the BDS was not designed to support analysis of incidents of adverse events or other occurrence data. Analysis of such data is supported in OCCDS. The BDS was not designed to support analysis of incidents. Okay, OCCDS does it. Occurrence analysis is the counting of subjects with a record or term. It often includes a structural hierarchy of dictionary coding categories. This is what we know, because if you see adverse event, concomitant, medical history, these are some of the things which come under OCCDS. Like start date. Example, what are the main areas or main variables which determine OCCDS, we have analysis start date and time, analysis start relative date, analysis end time and date, analysis end date, all these. If I go down, these are the ones which are very, very specific to OCCDS. Severity, relationship, toxicity. This is another tox here.
So can you tell about this talks here?
Toxicity for analysis may be based on any toxia or an imputed or assigned value. May change case of text such as all uppercase A toxia to mixed case in A toxia. Let's see in A toxia if we have something. Toxicity grade is A toxicity. How toxic basically? I remember 1 second. In A, let's see if we have A toxia. We'll have an idea about it. A toxia. How much standard toxicity grade of the adverse event? Toxicity grade according to the standard toxicity scale, such as common terminology criteria for adverse event. There is an adverse event scale which is there, CTCAE. Sponsor should specify name of the scale and version used in the metadata. See assumption 60. Let's see. In studies using toxicity grade according to standard toxicity scale, such as this one published by National Cancer Institute at this, A toxia should be used instead of A severity. Instead of severity, we are using A toxia. How severe it is, in the same way how toxic is the adverse event which is happening. So I remember A severity is in most cases either A severity or A toxia is populated, but not both. Okay, because we mainly have supported A severity. When we have mainly worked with A safe, hardly we have worked with toxia. But in case of A safe, you can do toxia. I think toxia is like A severity. We have mild, moderate, severe, life-threatening. Here we have grade 1, grade 2, grade 3, grade 4. It is represented as that. There may be cases when a sponsor may need to populate both variables. The sponsor is expected to provide the dictionary name and version used to map these terms utilizing external code list elements in the defined XML document. So if you see here, A toxia, we have not got an example here. But do we have A severity? Yes, we have severe, moderate, moderate like this. Similarly, here for A toxicity grade, we would have grade 2. See example 2 and not grade 2. Like whichever scale he is representing as per the common terminology, if it's grade 2, grade 1, I think it's less serious. Grade 2, I think it's a little bit more serious. Grade 3 is very more serious. Grade 4 is life-threatening. That is how the toxicity grade is calculated. Okay, clear, understood?
Yes, yes.
That's it. Like basically, you will use toxia, and also it is a permissible variable. If you see, if you keep it, if you not keep it, not a problem in the data set. It's not required, or it's not expected as well. It's absolutely permissible. Then we have this treatment variables in OCCDS, where exactly the time comes up, and where exactly the data set is featured in this way. Like we have the U subject ID, we have the sequence number, we have the adverse event term, we have the treatment emergent flag, analysis flag, we have the pre-treatment flag, PRE, I don't know this one, pre-treatment flag. Okay, before the treatment, if the headache
Before
and back pain. So probably they are correct. So after you've taken the drug, this is treatment emergent. So after taking the drug, the person had weakness, headache, hypotension, whatever. And before taking the drug only, like after enrolling in the study and having the screening done and after having the inclusion exclusion done, the person might have headache and back pain. But that is not related to the drug. That's why pre-treatment flag is yes for this. Then when is the analysis start date? When were these done? So we have the date. So this is important. Start date, end date, severity or intensity, A7 analysis severity. This is the severity which was given: mild, moderate, mild, severe, severe. These are the ones which were A severe was
SGM variable.
is absolutely, and A-safe is something which is the analysis after the Adam variable. Yes, absolutely correct. Absolutely. Then the actual treatment. Which treatment was it given? So the difference is the terminology changes a little bit. PRTA, A-safe, A-age. Then you will get about that severity. Then AEREL, relation, AREL, you will get AREL. Other action taken. Here you will get ACN, like that.
Yeah.
Analysis one. Here also, this is something where you have that A dictionary coded term. What is the treatment flag, follow-up flag, A period, A phase. Like we have the epoch, here we have A phase. First treatment, second treatment, follow-up. Similarly to that. Then we come to the basic data structure, BDS. BDS will focus on, see, these are, now we have parameters. The time takes a backseat. All those timing variables and severity takes a backseat. Here we have severity, but here if you see, we are more interested on the parameter. What parameters have been tested? What is the payment? What is the type? What is the parameter type? What is the parameter category? Like, is it biochemistry or is it something else, hematology? So which type of chemistry is that? What was the baseline value? Here we come for the baseline value. What is the baseline value? What is the change from baseline? What is the percentage change from baseline? All these comes in. Now, whenever we come to parameter and we have tested one particular parameter, suppose glucose, HbA1c, whatever, what is the value of it? Then eval comes in, because we are dealing with values here. What is the analysis value? So these are the important variables in BDS. So that is the difference what I wanted to make you understand. So these are the flags. We have ADLFL, analysis baseline flag. All these ones we have, record flag and so on. All these are not that much important. I mean, as you start working on it, when you are working on these, there are derivations you'll get to know slowly. That's not a problem.
I know this on treatment flag concept it is.
Okay, but
So
on treatment I have never worked on. Like on treatment I have not derived previously.
okay, okay.
So
No,
here,
I just prepared for the interview that concept.
that is okay.
Yeah. So the other one more flag is over there. Can you go in that? Can you go in that slide? So this is last visit treatment record flag, right?
Last,
Last value.
hmm,
So
what
so
is that?
what is that? Yeah.
I'm not very sure. Then we have to check that.
Okay.
Last value and treatment record. You don't get bogged down by all these flags. That's not. If you have the concept right, it's okay. Even for the interview preparation, if you are like, if you know about what is the flag, if you know about SAFFL, ITTFL, you know these. I've shared one
Mhm.
with you which has all those details. That is a good one. If you have some more flags, if you read about it, that's okay. But when we
Okay.
are doing it, all these are not required. Some of them will be required when we are actually doing hands-on, when you do hands-on going there. And if it is required for that amount of complex study, then probably it will be needed. But not before that. And that is okay. That is, these
Mhm.
concepts are important, but that is okay. Like that, those flag, I mean, based on the derivation, you will able to derive it. It's not a problem. So here, if you see timing variable conventions as a part of BDS. Okay, in BDS, there we also have some timing conventions, numeric date type. So here, what we had done in SDTM, so whatever data we have got, we have standardized it. Okay, even if we have got year and date, year and day, and the month is missing, we have represented SDTM in that exact way, because we did not make any imputation or we did not make any changes to that, modifications to that date. Okay, we have exactly represented it in SDTM as and how it has been collected from the patients during the study. But when we are doing ADAM analysis, we need to fill up and make the date. We have to impute the date to make it a particular date, like make it in a correct date format, date and time format. We can't just leave it in a way. So that is why there is one beautiful concept here, which let's check this out. So here, if you see in SDTM, we have got YYYY Okay. Suppose so missing as a date. So as a missing animal, do we have anything? We don't have anything. It's totally a date. So Adam date, what we will have? We will also have YYYY Exactly. And the imputation flag will be blank. We have not imputed anything. We have not imputed means we have not added any month, date, year, anything. Now day is missing. If you see YYYY So if you in SDTM we only have year, and for any particular record we only have year and month. Here we have imputed the date YYYY here. Okay. So if we have imputed the date here, so what is the imputation flag we'll have? DTF variable. What is the DTF variable? DTF variable is the date imputation flag. Imputation flag variable for analysis date time in ADF is ADF. So here what we have imputed a date. Since we have added a date to make it complete, in the ADTF column we will give a D. Understood?
Yes, yeah.
Now we have the month missing. YYYYDD. Okay. So here we have, since we have imputed the month, ADF will be month. Now month, day both are missing. Here if we see YYYYMMDD, we have imputed, if you see the hash sign, it is against month as well as date. So here in D, we will add only whichever is big, higher. Month is higher, we have added month. We have not added the date. Here if you see the year, we only have month and date, but we don't have the year here. So we have imputed the year, and ADF we have given year. Similarly, only if day is present and we don't have year and month, then we impute year and month here, and after that we give the imputation flag as well. Because year and month here is greater, we give Y. And if we don't have anything, we impute the entire date as 1st January for the starting of that year, 1st January 2025, and we give imputation flag as well. Here, this to give you a real-time example, this is one of the good examples we have. If you see 001 new subject ID, this is the A term header. This is the ASTDPC. This is the ASTDT that we have. This is the ASTDT. And so what we have imputed? We have imputed the time here. Okay. So, I mean, what we have imputed, AESTDTC, the start date was 2006-01. We don't have the date here. So, when we are doing ASTDT start date, we have done 11 January 2006. Okay. And if we have date time, what we have done 11 January 2006, 23:59:59. So what we have imputed in the ASTDTF imputation flag for the date, we have done a D, because here the date was missing, we did a D. And for the time, we have added hour, minute, seconds, but greater is hour, hence we have given here hour. If you see the next, we don't have anything.
So here is one question, Arshit. So 11 is a random date, right? It's not a first date or the end date, right? So can we take in that way? Or we just have to take the first day of the month?
First day, sorry. No, this is 11th is 2006 01. It
So
shouldn't be 11. It should have been 01. Correct. No, it shouldn't be 11. It should have been 01. It should have been 01. This is not correct here. We can't take any date. No, you're correct. This is 2006 01 is the month, and the date is missing. It should have been, if you are imputing date and its start, it should be 01. Correct. No, it is not correct. This 11 Jan is not correct. It should have been 01.
okay.
Yeah, correct. Because if you see the next one also, if it doesn't have a date, it should be 01 Jan 2006.
Yeah.
And then what we have imputed the year, we have imputed the hour, because nothing was there. So now if you go back, if you understand, so we have added the entire year, month, day. So as per date imputation, we would have given Y. And as per time imputation, we have given hour, minute, seconds. That's why we have given hour. The bigger one. Then if you see the next one, you will see we have 7th January 2006. We have got the hour, we have got the minutes. We don't have the seconds. So we have added the seconds. And also ASTTMF should have got seconds
I
here.
guess this date is incorrect, right? Here, 07 Jan and this is 21 Jan.
That is the problem. This is incorrect, yes. But here also something. So, but based on the logic, if you go by the logic, this is incorrect. But it should be
Yeah.
7th. It should have been 1 second. Percent, yes. So it should have been 7th
7 Jan.
2006 22:15:00. Here it should have been null because we have not imputed anything, right? The entire date is here, but here it should have been S second.
Yes, yeah.
Correct. The next one, let's see, we only have the year. So month and day should be added. So ADTF should be month. It is correct. It's 1st Jan 2006. Then we have here should be hours. Okay. Then here, if you see, that's a good example. Here we have the date, only the hour. So once we have done that, 23rd January 2006, 22:59:59, then we give here minutes. Because we have imputed minutes and seconds, but the greater one is minutes. That's why we have given. So this is an imputation flag that we have. Got it? Understood?
Yes, yeah.
Now let's go to ADCM.
So for the timing, we have to take the 23 hours, 59 minutes, 59 seconds. That way.
And start date. And similarly with the end date also, we will take the end date as well, like that. If it's 15 January, we will take it as 15 January 2006, 23:59:59. Or since another thing is also there, another concept is also there. Since it is start, I'll let you know. Since it is start date, you can also take, based on the study, 11 January 2006 00:00:00. Okay.
Okay. So you meant to say complete 0.
At 12 hours, 0 minutes, 0 seconds, like at the 12. So starting, okay, starting of that day, you take the ASTD, like start date time. And the end date time, you will take, suppose 12 Jan 2006 and this date, 23:59:59. The end date and the end time as well. The end time of, when is the end time of an entire day we have? It's 23:59:59, correct?
Yeah, yeah.
And when is the start time of a day? We have 00:00:00, correct? That's the start time. So that also you can take based on your study requirement. So go through this. This is normal, the definition of this concept. Now let's come to ADCM. Okay, ADCM, the exact thing that we described. So we have the parameters here. CM, so we have data CM. CM, we don't have the parameters because we are not checking anything. It's a concomitant mitigation. So it's a part of OCCDS. Okay. So here we have data CM1 is DTM. We are taking the data from CM. We are also taking the data from sub CM. Now, sub CM, if you see sub CM here, so if you see sub CM here, we have the ID where 1 second. So where we didn't have the ID. Oh, no, perfect, sorry. So what we are doing, so we are taking the data from the CM here. We are taking the data from sub CM here. Like ID variable, we are changing input ID variable with CM sequence. We are taking it in CM sequence. Then we are doing a prop transport of the sub-CM, and then what we are doing a merge. Simple, nothing else. What we have done all the way. So let's go here. CM2. Study, domain, new subject ID, CM sequence, CM treatment. So we have just merged CM sequence and so sub-CM had what? Sub-CM had probably got these ones. Did you see? Number of medical history term, code 1, code 2, text 1, text 2, all these specific questions, and we have just flipped them and merged it with CM. So we have all those row related questions in the sub-CM in as column related here. Fine. Now what we have in the specification, if you see in ADCM, CM sequence will be CM sequence, reported drug will be reported drug, CMRT. So these are all direct links from CM, so we don't have to do anything. So here ATC4 would be set to qval where subcm.qnum equal to code 4. So ATC4 equals to code 4. We are doing it, and ATC4 text equals to text 4. Yeah. Set to qval where subcm.qnum equals to, set to qval where subcm.qnum equals to code 4. Set to qval where subcm.qnum equals to text 4. So we have that exactly. Code 4, text 4. What is it in code 4, text 4? Let's quickly check. Text 4 is this one, and code 4 is, okay, these are some of the ATC codes that we have of the dictionary. Because when we have concomitant medication, the dictionary changes. It's not MedDrug. It is WHO drug dictionary. Okay. So for WHO drug also we have levels, ATC1 level 1, ATC level 2. Like in MedDrug we have low level, high, low level, preferred term, high level group term, SOC. Similarly, we have these levels in the WHO drug. So
it is in CM, you are saying, or in the Adam they use?
So in the CM also, in the CM data set also you will have that. It is for WHO drug dictionary mainly. So here
Okay.
if we go to CM domain here, and let's find out, because any adverse events, clinical events, we will map it to, but any drug related information, CM is what? A drug, correct?
Yeah.
CM is basically a drug. So we are
Yes.
giving a drug. So for that concomitant medication, we have to use a separate dictionary, which is WHO drug dictionary. But for medical history, if we are giving a drug, suppose, see how beautiful it is. If for medical history, what we have, medical history has, like, a person has diabetes, or a person has, suppose, arthritis or COPD, whatever, as a medical history. Those are events. Those will go into the medical history is there. Those will be mapped to MedDrug dictionary. But the medicine which is the person is taken for those medical history that the person has will go under concomitant medication, correct? And those medicines will be linked to WHO drug dictionary.
Okay.
Standardized or dictionary derived text description of CMTRT or CM modify equivalent to the generic drug name in WHO drug. The sponsor is expected to provide the dictionary name and version used to map the terms utilizing the external code list element in this one. If an intervention term does not have a decode value in the dictionary, then CM decode will left blank. Okay, these are the part of dictionary. If you see an example below, I don't know, I don't think they have given for ATC text here. They have not given an example. But this is how this is related. Who Drug Dictionary. It has ATC level 1, ATC level 2, ATC level 3. You can, if you just Google it, you will get to know about it. That's nothing rocket science here. So here ATC 4 links to code 4 and this one links to code 4. So if you see here, ATC 4 is occurrence data structure, ATC level 4 code and ATC level 4 code. So what is the code and what is the text? So ATC 4 is probably a higher code. So which code it is basically? What is the code? And what does the code indicate? That comes under text. If you see here, the code indicates this is a particular code for a particular drug, and the text of that code ATC4 is text for dihydropyrimidine derivatives, like that. So for 3, like we have like we have exactly similar LLT code, LLT name, PT code, PT name, HLT code, HLT code name. Similarly, we have it here. ATC code 1, we have this for a drug, then code 2, code 3, code 4, and their corresponding text is text 1, text 2, text 3, text 4. Cardiovascular system, calcium channel blockers, selective calcium channel blockers with mainly vascular effects. This is the difference. Understood?
Yeah.
Got it? Now, this part I'll explain, and the rest of the part you can easily go through it. I'll not explain. You can go through it. This is very easy. This is very, very easy. I mean, the rest of the part is easy, but this one is an important part. Understand it. So we are starting with a 1 second. Data CM3. Let us start with this one. CM4. Okay, 1 second. Okay, fine. Now let's focus on this. So if we have, so we are first starting with CMST DTC underscore. Okay, we have given a new variable CM underscore DTC underscore, and we are doing substring CMST DT 1 to 10. Okay, 1 to 10 means the date part. We are substringing it. Now what we are doing, we are substringing the date part from CMST DTC. CMST DTC is the start date of the CM start date. We are taking the for length 1 to 10 because CMST DTC might have time also. We are not concerned about time one. So when we are doing CMST DTC underscore 1 to 10, we are taking the date and putting it in this variable. Okay. After that, what we are doing, we are calculating the length of this variable. How many length is that? Do we have the full date? If it's full date, we will have 10. Y dash mm dash dd. And if we do not have the full length, that means the length would come less. So how we have tried to tackle this? If length is 4, then do CMST DTC underscore C is strip CMST DTC underscore, and we concatenate it with 0101. What does 4 means? If the length is 4, what do we have? What do you guess based on your idea? What do we have in the entire date?
Year.
Absolutely, we only have the year. That's why we are imputing what? Month and date. Now coming back to the concepts which I just explained, which we just discussed some time back. Same thing is happening here. So what we are doing? 0101. Okay. So we are imputing month and day. And the AM and the imputation flag will have M. Yes or no?
Yes, yeah.
Absolutely, because month is higher. Let's take an example. CMST DDC underscore is 1999. CMST DDC underscore C is this. Is it CMST underscore C? Yes, CMST underscore DDC is C. Strip this one, 0101. Underscore C will be 1999 0101. ASTDDF will be M. And then ASTDD, we have changed this to this one. So that is easy, that you know, that probably we have done it later. Okay, so we have done this one. Fine. Next is if length is 7, what all do we have? What do you think we have?
So we have month and year here.
Correct. So what we impute day, ASTDDF is equal to D. Fine. We have something like this, D. Let's go down. Yes, we have here 2021-05. We have imputed the date and we have D here. So this concept is clear. And length is 10, we keep ASTDDF as null. So all the null ASTDDF we have, that means it has everything. So this is everything. That's why it's null. Everything null. Everything null. So on and so forth. Complete. Now we come down to end date. End date is a little bit tricky here. Let's go one by one. Okay. So suppose CMST, same thing. If it is 4, we have this one. We have given 12 31st. It's end, right? So end of the year. If we only have the year, so if it's end date, we will do 31st 12. So if the start date we are annotating as 0101, end we would do 31st December. Agreed? And A in DATF will be marked. Similarly, if length is 10, we don't do anything. Now the funda is, suppose we have 7. Okay. We have year and month. Can you give 01? Can you give 31? As the like here we have 7, we gave 01. But here
Yeah.
can you give 31 directly? If it's 7? 7 means
No,
what?
no, no.
Why no?
Day. It's a day is there, right?
Day is there, then we can give 31, last day of the month.
Yeah, but every month is not the 31st, like
Absolutely.
30.
That is where the trick comes in. Correct. Got it. So this is an important thing that we need to. I mean, you got the concept. Now it's easy. So what do we do? So we have this date. Okay. Fine.
Yeah.
We impute 01 here. We do month. First, what we are doing, input strip CMDC underscore and 01 in YYMMDD format. Okay. So what do we come up with? We have this one now. Take a look into it. Okay. So
Yeah.
once we have imputed it, we have now this one. Suppose it is 202303. The date is here, 7. Okay, we don't know. It may be 0405. Let's take 03 here. Fine.
Mm-hmm.
Now, once we have imputed 01, it becomes 20230301. Agreed?
Yeah.
Then what we are doing, int nx, we are selecting the month and incrementing it by 1. Int nx function. Take int nx function, okay? You pick up the month and then what you do? You increment it by 1. It is used to increment the months or increment values. Int nx, integer nx, okay? This was taught, you got an idea of int nx before?
Yeah, I know that.
You know that perfect.
At
Okay.
least there is a zero. We need a zero, right? We don't want to month to be changed, isn't it?
One second, let me come.
I don't think so. There is a one. So
Uh,
month will be changed, right? Here.
month will be changed. So now we have month 20230401.
Yeah.
So 1 month has changed.
Yes. Yeah.
Now then we do -1. One date we subtract it. So we come to this month which is already there and we come to the last day of the month. Got it?
Okay. Yeah.
So whichever month is here, we are imputing 01 with it. Incrementing that by 1 month, then subtracting 1 day. So whatever be the month, be it September, October, whatever, whenever we subtract the first day of the next month by -1, we get the last day of the previous month. If it's 31, it will be 31. If it's 30, it's 30. Similarly, if you see 202329, this we get 01 we impute, then we get first, and then if we go for September, we get 30. Clear?
Yeah.
This is the trick. So this is an important one which you can go ahead with. Any questions?
No. No. We can directly give there, right, at the end of the month. E. E is the modifier if we give there, isn't it?
Give
In
where?
the
Here.
function. Yeah.
No,
If
here you can.
we increment 0 and E, put it, that is also fine, right?
That is also fine, but you can try. But I have not tried that. That you can try once. But
Okay.
this is the best way that you can actually represent this concept. The
Okay.
last day of the month. Yes. If it's even February, you won't have a problem.
Yeah.
You will get 28th or 29th. Okay. The rest is the same. I've shared with you the specification. Check the ADCM. Okay.
Okay.
This is it. And for LB, this is an OCCDS. Sorry, LB is BDS. So
Yeah.
here ADCM I have given you. I'll also share with you ADAE. You can check that. That's not difficult. ADCM is also not difficult. You understand ADLB, okay? Take a look at ADLB. There's nothing different because you've understood the param and param CD. You've got that. So based on the specification, you can easily understand this. But one thing in ADLB I wanted you to know, that is, if you see here, there is a shortcoming here, which we have adjusted and then started with ADLB. That is, if you go to SDTM and if you go to sub LB, ID var is LB sequence. ID var should have values, right? Otherwise, how would we map it? Or how would we merge it with LB? Every sub has, like if you see sub DM will not have. If you see sub AE, it has ID var values, correct? This is basically AE sequence, correct?
Yes.
So sub LB, this is basically LB sequence, which we would actually merge it with LB sequence of LB, and then we will get the entire data set over which we can start the analysis of ADLB. Agree with me?
Yes, yeah.
But here it is not there. That is why to make the adjustment, what we have done is data LB is correct. Then what we have done for sub LB is we have made a addition. Correct. Absolutely. So data sub LB1, set sub LB sequence is input this one. After that, what we have done from a sub LB, set sub LB2, by U subject ID, if first dot U subject ID, then LB sequence equals to 1, else LB sequence plus 1. So now if we go and to look into sub LB2, let's see how sub LB2 is. In the work directory, if you see sub LB2, how is it done? LB sequences 1, 1, 1, 1, 1, 1, all these are 1. LB sequence, but 1 second. Okay, so we have how many sub LB? 8, 9, 10. Okay, we have distinct values in LB here. Okay, that's why all are 1. Okay. So probably, do we have only one question that is being asked? Q num, Q level. Okay, test level comments. There's only one question that is being asked. Okay. Let's see sub LB. Okay. We have only one question, which is that's why we don't have a sequence here. Then for every patient, we will have one question from sub LB attached to it, not multiple. Then we have given this merge, and that's it. Then we have this merge LB1 and sub LB trans. We have LB2. Okay, we have also merged LB2 with ADSL because we need some of the data from ADSL as well. Okay, because be it ADLB, be it ADAE, whatever, we also need data from ADSL for that. ADSL is basically the subject level analysis dataset. So there we have. And then we have given based on one after the other. We will see the param and param CD high, low values. It's the same based on the specific. You'll be able to handle that. Not a problem. Otherwise, you can let me know. Not a problem. We can get that done. Okay. Wait. I'll stop the recording.